we'll do two together, and then you do two on your own. So the volume of this polyhedron, first of all, what kind of polyhedron is it? They haven't shown me the transparent view, but I can tell it's got two parallel and congruent rectangular bases, so it's a rectangular prism. So since it's a prism, I can use my new volume formula, which works for all prisms and cylinders. Volume equals area of the base times the height. Well, I can tell the height is 4 inches because that's how far apart the bases are. This is the height of prism. But I can't do the formula because I don't know big B yet. I don't know the area of the base. B is area of the base shape. Well, let's look at the base shape. It's a rectangle. It's a 5 by 2 rectangle. So big B, area of the base, I use the rectangle formula, base times height. So 5 multiplied by 2 is 10. So the area of that base rectangle is 10. Just like the area of this base rectangle was 15. Now I can substitute into this formula. Volume equals 10, because big B is 10, multiplied by the height of the prism, which is 4. So the volume equals 40 inches cubed, because it's three-dimensional. We're talking about how many cubes worth of, how many cubic inches, how many 1 inch by 1 inch by 1 inch cubes would fit inside this rectangular box, for example. Each layer is 10 cubes, but there are 4 layers. The other thing that gets confusing about this is height. There's two different heights. This is the height of the rectangular base right here, but this is the height of the prism. So you have to understand in which context you're using height, and that'll take practice, but we'll get there. I put the draw it slide on the next slide. You can use it or not use it. If you're doing this on notes, obviously you don't need to use it. You can skip forward to the next one.